The last couple of days, we've been talking about testing a claim. Sometimes that's called a significance test. Here's a question. Did these two guys that are in a cardboard car, were they able to pull it off and actually get served at a fast food drive-through? I don't have the answer to that question. But let's talk about another question. The manager at this fast food drive-through wants to make sure that his customers don't wait more than 2 minutes. Well, he looks at some records and he finds out that 63% of the customers wait at least 2 minutes. He wants to reduce that. So what he does is he hires another employee that's assigned to just helping out with the fast food, with the drive-through orders. So after a month of this, he collects a random sample of data and tests his hypothesis. Now, what is his hypothesis? Think about that for a second. So when you're watching these videos, you can always pause it if I'm asking a question and think about the answer or write the answer down and then start the video again and then you see what I say. Alright, so let's think about these hypotheses. We have the null hypothesis. Now the nickname of the null hypothesis, H sub 0, is no change, which means that the percentage of people who wait 2 minutes or more for drive-through stays at 63%. The alternative hypothesis would be that this percentage of people that wait goes down. That's our goal. Alright, and the way we do that is by hiring that employee. So that's what we're trying to do. Let's think about type 1 and type 2 errors. So a type 1 error is when you reject the null hypothesis in favor of the alternative hypothesis, even though the null hypothesis is true. Okay, that's a mistake. What are the consequences of that mistake in this situation? So in this situation, we say, okay, we hired that new employee, and it seems like the wait times are going down, which is not true. What are the consequences of that? The consequences is we are paying an employee thinking that they're helping our business by decreasing wait times, but they're not helping at all. So we're kind of wasting money on hiring this person, not improving our business. Now, let's talk about a type 2. So a type 2 error is when you fail to reject the null hypothesis, even though it's false. So a type 2 is when you say, okay, I don't really have enough evidence to go with the alternative hypothesis, so I think things stayed the same. But it's not true. It actually did go down. Okay, what are the consequences in this situation of a type 2 error? Well, the type 2 error is you hired this person and you have a feeling that it didn't change anything at all. So what are the consequences? Actually, but they did. So what are the consequences of that? Well, the consequences are you would probably fire the person because you're thinking they're not helping out at all when they actually are. And then even further down the line, you're thinking, okay, I still want to fix this problem and I don't know how to do it. So that becomes really problematic because you made a type 2 error. Now let's continue with this. Let's assume that the manager of this restaurant takes a simple random sample of 250 orders and wants to test this at a significance level of 10%. Okay, what does that mean? So, well, so far we got some information. So the sample size is 250, and then also our alpha level, right? The significance level at 0.10, like that. Okay, so let's start with that. And there's a couple of things. We kind of like in the last chapter where we have to test random, normal, independent. We look at the shape, the center, and the spread of this situation. So let me write that down. Well, just like we've done before, shape, is it normal? Well, this is a proportion, so how do we figure that out? Okay, we would say 0.63 times 250. Is that bigger than 10? Yes. And then also 1 minus that, which is going to be what is it, 37 times 250. Is that bigger than 10? And the answer is yes. Okay, this pen is not working. 0.37. There we go, I think. Good. So shape approximately normal. Now the center. Where is the center of this thing? Well, it's going to be at 0.63. How do we know that? Well, let's see. We know that if we took many samples, right, and took the proportions of those many samples, what would that approximate? Well, it would approximately be the same as the population, 0.63. What is that called? What is that again? Unbiased estimator, remember? Okay. Now, the spread, what does that have to do with? Well, that is the standard deviation. How do we figure out the new standard deviation? Oh, yes, we've got the new standard deviation is going to be, so standard deviation of p hat is going to be the square root of 0.63 times 0.37, all divided by 250. There's our new standard deviation. So, shape, center, spread. All right, let's go to the next thing. So here's a rough sketch of a normal curve, and in this situation, where is the middle? Well, 0.63. And where are we at? Well, we are at an alpha level of 10%, so 10% of the data is right there. Okay, now, so in this situation, if we get a value that puts us somewhere in here, meaning it's kind of unlikely, 10% or less probability that we would see that value given the situation, we would reject the null hypothesis. Now, assuming that it's actually true, if the null hypothesis is actually true and we get a value in here kind of unluckily, and we reject it, that is a type 1 error. Okay, now what's the probability that you get a type 1 error? Well, if you're anywhere in this area, right, we have a 10% chance of being in this area just by luck. So the probability of making a type 1 error is the same as the alpha level. So once again, if we take a random sample of 250 and we get the proportion, and it's any number in here, okay, I'm not going to calculate what those numbers are. I think I might have gotten ahead of myself during class today. But if we get a number that's in here, we fail to reject the null hypothesis. But if we get a number up in here, okay, that would give us basically what we're saying is a low p-value. Okay, anything that is in this area, we're going to reject the null hypothesis, saying it's just not very likely that we would get something up in this area. And what is the level that we would accept? That 10%. Okay, that's our alpha level. Statistically significant. Okay. Now the last piece of this thing is called the power of the test. Think of the power of the test as the sensitivity in the test. Now, I was reading the book and I noticed, where is it? After really struggling with this a little bit back here, at the very end it says, let's see, calculating a type 2 error probability or power by hand is possible but unpleasant. Really? Okay. It's better to let technology to do the work for you. I also noticed that it says in the teacher's binder that, where is it? It says students will not be expected to calculate the probability of a type 2 error or the power on the AP exam. Yes, but we kind of have to know what it is. Now, one of the big things about power is, again, sensitivity. So, what helps us get better data? Well, a bigger sample size. That always is helpful. So if you increase the sample size, you increase the power. And I'm going to leave it right there until I see you next time.